Okay, 2.4 is being broken up into two parts, and after we get to part B, you will see why. So we're going to start with 2.4a, solving equations with variables on both sides. So we are still going to solve for x, and luckily there's only one variable x, but it happens to be on the left side of the equals and on the right side of the equals. So let's jump in. We're still going to draw a line down the equals. And what I want you to do first, I bet your gut instinct is to either subtract 2 or subtract 14 from both sides. And I want you to fight that urge with all that you can. We do not want to move the constant until last. It's just a little bit easier if you get in the habit of moving one of the variables to the other side first. So if we get rid of one of the variables by moving it to the other side, then you can solve the equation like you're used to doing with all of the others. So you can move either one. It doesn't matter which one. If you are moving a 5x, you're moving the whole thing. You are not dividing these two because you're not dividing the 5 from the x. You're taking the entire unit 5x and subtracting it to the other side. Or you are taking the 2x and subtracting the entire term to the other side. I'm going to tell you why I choose to subtract the 2x. I usually mess up when it comes to negatives. And if I were to subtract 5x from both sides, 2x minus 5x would be a -3. And so I'm just going to choose to avoid that negative. So I am going to subtract 2x. What you do to one side, you're going to have to also do to the other. And I'm lining it up with the other x because they are like terms. So on the right, 2x minus 2x is nothing, so those cancel out. On the left, 5x minus 2x is 3x. Notice we're still keeping the coefficient with the variable. We're keeping them together as one unit. Bring down the plus 2. Bring down the 14 over here, and now you see why we left the 2 and the 14 alone, because now you're left with a basic two-step equation. And now you would subtract 2 from both sides. You would bring down your 3x. 14 minus 2 is 12. And the last step, you would divide to separate. Now the term can be separated. Let's divide both sides by 3. So that we can get x completely by itself. 12 divided by 3 is 4. Okay, so again, when you see a variable on the left and on the right, take a moment to move by subtracting if it's positive or adding it to both sides if it happened to have been negative. Let's try the got it. If you're ready to try the got it, pause the video and go ahead and try this one on your own. Okay, so again, move the variable first. Fight the urge to subtract 2 or add 10. Leave those alone for now. We want to move a higher priority first. Again, it doesn't really matter, actually. If you were to subtract 2, it's fine. It just usually confuses students when they're left with something that looks different than how we did it up here. So I'm going to choose to subtract 4k because, again, if I subtracted 7k, that's going to give me a negative over here, and I just try to avoid negatives if possible. So I'm going to choose to minus 4k from both sides. I'm going to cancel it over here. 7k minus 4k is 3k. Bring down my plus 2. Bring down my equals. Bring down. That is a -10. Please be sure to know that the symbol in front of it, even though you probably read it as a minus, that is a negative, which is the same thing as a minus. It just happens to go with its term. So that was, if you brought down a 10, you probably did it wrong. Now we would go ahead and subtract 2 from both sides. Bring down your 3k. Remember, -10 minus 2 more is not 8 or -8. If you're -10 in your lunch account and you subtract out $2 more, you are -12. Or if you're nervous about missing a problem like that, just go ahead and use your calculator every time. Divide both sides by 3. K would be equal to -12 divided by 3, which is -4. Okay. All right, we are going to go ahead and move on and try it with grouping symbols now. It's still the same process. You're just going to distribute over here first, distribute over here, and then we'll be left with a problem like we did up above. All right, so 2 times the quantity 5x would be 10x. 2 times -1, remember you need to read that as a -1, is -2 or -2, which is the same thing. 3 times x, just squish it together, it becomes 3x. 3 times +11 is +33, so the plus goes with it. All right, now we're left with an equation that looks like these that we started with earlier today. So you are going to move one of the variables to combine it with its other side first. I am going to choose to subtract 3x, again to avoid negatives, but if you want to subtract 10x and get -7, you work it out and you would get the exact same answer I would. So it really doesn't matter which one you move. That's just a personal preference for me. Okay, 10x minus 3x is +7x, unlike what would have been over here. Bring down your -2, bring down your equals, bring down your 33, it's positive, so you don't need a plus sign there. And now you're left with a basic two-step equation. We would add 2 next, bring down your 7x, 33 plus 2 is 35, and last step, divide both sides by that 7 to get your variable completely by itself and isolated. 35 divided by 7 is 5. Okay, we've got a couple of got it's for you to try if you want. So if you do want to, pause the video and try these, but be sure to check back and make sure you did them correctly. Okay, if you are checking your work or working it out with me, either way is fine. Distribute 4 times 2y, which is 8y. 4 times +1 is 4, but you need to have a symbol in between it, so put a +4. Equals 2 times y is 2y. 2 times that is a -13 is -26, so it's going to look like -26. Okay, and then move a variable to the other side first. I really wish one of these was negative so you could see that you would add it if it was negative. All of these have been positive. So we have been subtracting on every single one, which is okay. I think you would still know what to do in the case of a negative, but I'm choosing to subtract 2y. That would leave 6y plus 4 and -26. Don't forget to bring down your negative. A little thing like that will mess up your whole problem. Subtract 4 from both sides. Bring down your 6y. -26 minus 4, remember, is a greater negative, -30. And again, just use your calculator if you're not sure. Divide both sides by 6. Y equals -30 divided by 6, which is -5. All right, last one. Distribute first. 7 times 4 is 28. 7 times, here's one, a -a. This would be negative, squish them together, 7a. All right, 3 times a is 3a, and 3 times -4, that's a -4, even though it looks like a minus, they're the same thing, is -12. So it's going to look like -12. Okay, here's what I was talking about. You have a -7a and a +3a, and we want to move one of these next. I could -3a, but that would be -7 minus 3 more, and it's -10a, which is fine. And if you want to do that, you do that. But I like to get rid of negatives whenever possible, so my personal preference is going to be to add 7a to both sides. So I'm going to line them up, the variable that it matches with, that it's a like term with. I'm going to cancel out the -7a plus 7a because that would be 0. They'd cancel each other out. It leaves only 28 over here. On the right, I'm going to add 3a plus 7a. See how this time we added instead of subtracting because we were doing the opposite operation to get it to move over here. And that is 10a. Bring down my -12. All right, you're left with the basic two-step 7th grade equation. So you're going to add 12 next. add 12. 28 plus 12 is 40. And then bring down your 10a. All right, last step, divide both sides by 10 to get a completely by itself. And so a would be equal to 4.